Okay, this is SPI 9.6. We're looking at the different states of matter. So the SPI, what you're doing is we're going to compare the particle, and you're going to find out that you could interchange the word atom here. Okay, the particle or atom arrangement and motion that's associated with the different states of matter. Now, there are 4 states of matter in which all substances exist. We're really going to focus on 3: solid, liquid, and gas. We will talk about plasma, okay, introduce it to you, but we're mainly going to focus on those 3. Okay, so the first state of matter here that you need to label is what the particle arrangement and motion looks like in a gas, okay, and we're going to talk about this specifically. All right, so particles move around freely, okay, and they bounce off one another, and that says bounce and bounce, okay? But you need to know that when gas particles hit, they're moving around freely and they bounce around each other, okay? You can see here, if those 2 were to hit, it would then go another direction, okay? They bounce freely. Particles are, as you can see in this little picture, they are spread out, okay? And gas particles have a high amount of energy, okay? So this is what a substance that is a gas at the molecular, at the particle level, this is what it looks like. Okay, moving on. This is a liquid, and you can see here this jar, the liquid is being poured out. Now, once you think about how liquids pour, it makes sense into the particle motion, because particles can roll over and under one another, okay? So they can slide past each other, for say, okay? Let's talk about the arrangement. Particles are closely packed but can still move. I want you to add by rolling off each other, okay? So when we're talking about liquid, they're touching, okay, but they can still slide past each other, okay? So liquids slide past each other. All right, now we're moving on to talking about a solid. You can see here a solid. This makes sense when we look at this picture of a solid. Okay, and these particles are in a fixed position. Notice that they're specifically located. This solid is a cube, okay, and this cube, every particle is in a fixed location. What's neat about solids that you probably don't realize is their particle arrangement. They're extremely closely packed, but they vibrate in place. So I know the last fun sheet we did, I told you that atoms are always in motion, okay? Well, atoms or particles are also always vibrating, okay? All right, so here's the 4th state of matter. It needs to be mentioned. Plasma is the 4th state of matter, okay? And particles move 1,000 times at least faster than those in gas. So if I was to try to show you a picture, kind of like looking at the gas one, you wouldn't even see a particle in that screen, okay, because they move that extremely fast. Here's some examples of plasma, just to give you an idea. Lightning, the sun's rays, and when I say sun's rays, the sun's rays are actually not even made of matter, so it's not necessarily talking about the rays, but it's talking about the hot gases, the mega heated, and they don't even call them gas because they're so hot that the sun expels, okay? So that's called plasma. All right, and also the northern lights, and we'll remind me, and we'll need to look at a picture of the northern lights if you've not seen those before, and it's also in your textbook. Look at those. All right, so to change between states of matter, you need to change the temperature or the energy. That makes sense. Guys, if I have a gas and I want it to be a liquid, what do? I cool it down. It's going to make those particles move more slowly. If I have a liquid and I want to turn it into a gas, what do? I heat it up. So if I have a pot of water and that's liquid water and I want to turn it into a gas, okay, I put it on what? A hot stove. I add heat. I add energy to it, okay? All right, also if I want to go from a liquid to solid, I cool it. If I want to turn water into ice, what do? I put it into the refrigerator, okay? So I cool it. or I remove heat away from it, either way you want to say. So something you need to note, and this is our last note on this one, is that as temperature increases, so does the particle movement speed. So as temperature goes up, those particles start moving a lot more faster. Okay? All right, guys. That's it for the SPI 9.6 looking at states of matter.